Welcome back, everybody. Today we're going way back to the early solar system.
Oh, yeah.
Back when the giant planets were, they were really shaking things up.
Yeah.
It was basically like a cosmic game of bumper cars out there.
Yeah, a real free-for-all.
And we're going to try to figure out how all that chaos might be connected to the moon.
The moon.
Yeah, the moon. We'll be diving into this new article from the AAAS.
Oh, cool.
It's called How Ancient Collisions Explain Current Planetary Orbits.
Okay.
Published just this week, so it's hot off the presses.
Very cool.
Have you ever wondered how the planets ended up where they are? Because it wasn't always so neat and tidy.
No, definitely not. Back then, it was pretty wild.
Right. So for a long time now, scientists have known that those giant planets, like Jupiter, they didn't always stay put.
Oh, yeah. They definitely got around.
Yeah, they migrated outward over millions and millions of years.
It's true. But the exact timing of all that has always been a bit of a mystery.
A mystery. So how did they finally figure it out?
Well, the secret lies in these really cool space rocks.
Space rocks.
Yeah, they're called enstatite chondrites.
Enstatite chondrites.
Yeah, basically, they're meteorites, but they're low in iron, which makes them special.
Okay, so why are these low iron meteorites so important?
Because they're like little time capsules from the early solar system.
Okay, I'm listening.
Researchers have actually linked these enstatite chondrites to a giant collision.
A collision?
Yeah, a massive one that created a whole family of asteroids called the Asteroid family.
The Asteroid family of asteroids.
Yeah, it happened like 3 billion years ago.
Wow.
So picture this. Asteroids smashing into each other.
Oh,
sending debris flying everywhere.
Sounds chaotic.
It was. And some of that debris ended up becoming the enstatite chondrites that we find today.
Ah, I see.
Yeah.
So we've got these meteorites linked to this huge asteroid collision.
Right.
But how does any of that tell us when Jupiter and the other gas giants decided to move?
Well, scientists use this really clever technique. It analyzes the heat history of rocks to figure out how old they are.
Interesting.
And they combine that with these really complex computer simulations.
Yeah.
You know, about how things move around in the solar system.
Right.
And by putting all of that together, they figured out that the giant planet's migration, it probably happened between 60 and 100 million years after the solar system first formed.
Okay, 60 to 100 million years. Why is that significant?
Because, get this, that time frame overlaps with another really big event.
Oh.
The giant impact that scientists think created the moon.
Wait a minute. Are you saying that Jupiter moving could be connected to how the moon formed?
It's a pretty compelling possibility, isn't it?
Yeah, that's mind-blowing.
I know, right?
But hold on. How do they even know that these specific meteorites came from that specific asteroid family?
That's like a cosmic fingerprint match.
Yeah, fingerprint match?
Yeah, they analyzed the chemical makeup of the enstatite chondrites and compared it to the asteroids in the Asteroid family. And they found a really strong similarity.
Wow, so they really did come from the same place.
Exactly. So these tiny meteorites have helped us uncover this huge period of change in our solar system.
Yeah.
A period that really shaped the world we live on.
It's incredible how something so small can tell us so much about the past.
It really is amazing.
So knowing all this, how does this ancient history actually affect us here on Earth? And what's the significance?
We see, it really shows us that these events that happened so long ago can still have a huge impact on us today.
Right.
Like take the moon, for example. It's not just a pretty face in the sky.
Yeah.
It does some really important things. It stabilizes Earth's rotation, influences the tides, even affects our climate.
Wow.
Without the moon, life on Earth might be completely different.
I mean, not even here at all.
Yeah, it's crazy to think about.
So the moon is more than just a pretty face.
Yeah, for sure.
It's crucial for life itself.
Exactly.
And to think that its existence could be tied to these giant planets moving billions of years ago?
Oh, no, right.
That's just incredible.
Yeah, it's amazing.
Speaking of the early solar system, you mentioned that the giant planets' migration might have caused this period of intense bombardment.
Oh, yeah?
Called the Late Heavy Bombardment.
Right.
What exactly was that?
So imagine a ton of asteroids and comets just raining down on the inner planets.
All at the same time.
Yeah, pretty much like a cosmic rain of fire.
And this was happening to Earth, too.
Oh, yeah. Earth got hit hard.
Wow.
This was about 4 billion years ago.
4 billion years ago. That's a long time ago.
I know, and it really left its mark.
So how do scientists know this even happened?
Well, the moon is actually a big clue.
The moon again?
Yeah, if you look at its surface, it's covered in craters.
Right.
And a lot of those craters date back to this same period 4 billion years ago.
So the moon is like a giant record keeper of these ancient impacts.
Exactly.
Okay.
And it's not just the moon either. We see similar evidence on other planets and moons too.
Like where?
Like Mercury and Mars.
So it was a solar system-wide event.
Pretty much.
Okay, so we've got the moon, Mercury, Mars, all showing these signs of the late heavy bombardment. But what about Earth? I mean, we don't see nearly as many craters here.
That's because Earth is constantly changing.
What do you mean?
Well, we have plate tectonics, volcanoes, erosion.
Right.
All these things are constantly reshaping our planet, wiping away the evidence of those ancient impacts.
So even though we don't see the craters, the late heavy bombardment still had a lasting effect on Earth.
Absolutely. In fact, it might be one of the reasons we have water here.
What? Are you serious?
Yeah, comets are basically giant balls of ice and dust.
Okay.
And during the late heavy bombardment, tons of them would have crashed into Earth.
Yeah.
And potentially brought huge amounts of water with them.
Wait, are you saying that the water we drink, the oceans we swim in, all that water might have come from comets?
It's definitely a possibility.
Wow, that's amazing.
And comets also carry these things called organic molecules, which are the building blocks of life.
So maybe this bombardment didn't just bring water.
Right? Maybe it also brought some of the key ingredients for life to get started.
So this late heavy bombardment was both destructive and creative.
Yeah, it's kind of wild, isn't it? It might have ravaged the early Earth, but it also might have brought the stuff needed for life to begin.
That's a pretty incredible paradox.
I know, it's amazing.
But let's go back to the main story for a second.
Okay.
The link between this planetary migration and the formation of the moon.
Right.
You said that the timing of those events overlaps.
Yeah.
But how exactly could the giant planets moving cause the moon to form?
Well, one idea is that all that movement caused some serious gravitational disruptions.
Uh-huh.
And that might have sent a Mars-sized object smashing into Earth.
A Mars-sized object?
Yeah, that collision would have been huge.
I bet.
It would have blasted tons of debris into space, and some of
that.
that debris eventually came together to form the moon.
Wow, so it's like a chain reaction.
Exactly.
The giant planets move, things get started up, and boom, we get the moon.
It's amazing how everything is connected.
But if this impact was so big, shouldn't there be some trace of that Mars-sized object left behind?
Well, the impact that formed the moon was so powerful that it basically vaporized both the impactor and a good chunk of Earth's mantle.
Vaporized?
Yeah, it was like turning them into a giant cloud of superheated gas.
Oh, wow.
And all that material got mixed together and flung out into space.
And that's what formed the moon.
Right, that's the idea.
So the impact was so intense that it basically erased any trace of what hit us.
Exactly. It was like a cosmic reset button.
That's just mind-boggling to think about.
I know, right?
You mentioned earlier that these enstatite chondrites helped scientists figure out the timing of the giant planet's migration. How exactly did they do that? What information did they get from these meteorites?
Well, remember, the enstatite chondrites are thought to have come from the Asteroid family of asteroids.
Right, the ones that were created by that massive collision.
Exactly. And by studying the composition of these meteorites, scientists realized they formed in a region of the solar system that was heavily influenced by the giant planet's gravity.
So the meteorites carry a kind of fingerprint of the giant planets being there.
You got it.
That's so cool.
And since we know when the Asteroid family collision happened,
yeah,
we can use that information to figure out when the giant planets were in that particular part of the solar system.
It's like a giant cosmic detective story.
It really is.
With these tiny meteorites providing the clues to reconstruct what happened billions of years ago.
They might be small, but they hold so much information about our solar system's history.
It's amazing what scientists can learn from these seemingly insignificant objects.
It really shows you that every piece of the puzzle matters.
So much has happened to shape our solar system into what we see today.
Oh yeah, it's been a wild ride.
And it's thanks to these incredible discoveries that we're able to learn about it all.
And we're still learning new things all the time.
This has been a fascinating deep dive into the early solar system. We've explored the evidence of planetary migration, the mystery of the moon's formation, and the potential role of the late heavy bombardment in making Earth habitable.
It's incredible to think about.
But as with any good scientific investigation, I'm sure we're left with more questions than answers.
Oh, definitely. That's the beauty of science, isn't it? Always more to discover.
So what are some of the big questions that scientists are still trying to figure out? What mysteries are left to solve?
Well, we've talked about when these planets moved, but we still don't really know how.
We know they moved, but we don't know why they decided to head for the outer solar system.
Exactly. What caused it all?
Yeah. What was the trigger?
Were there other planets, maybe even bigger ones that we don't know about, that played a role?
Those are some pretty big questions.
They really are, and they keep a lot of planetary scientists up at night.
It's like having a puzzle piece, but not knowing where it goes in the puzzle.
Yeah, that's a great way to put it.
It makes you wonder, what if the giant planets had never moved? What would our solar system be like today?
That's a really interesting question. Some scientists think that if the giant planets had stayed put, the inner solar system would be way more chaotic.
You mean even more collisions than we've already talked about?
Probably, yeah. The gravity of the giant planets would have messed with the asteroid belt, sending more asteroids towards the inner planets.
So Earth might have been hit even harder.
Oh, yeah, for sure. And it might have made it impossible for life to get started here.
So in a way, maybe it's a good thing that the giant planets moved?
Maybe, yeah. It could have been what saved us from a much more dangerous early solar system.
Wow. So the same planets that might have caused all of that chaos could have also been what protected us.
It's funny how things work out, doesn't it?
It's a delicate balance.
Exactly.
Well, we've covered a lot of ground today.
We have.
We talked about evidence for planetary migration, the mystery of how the moon formed, and the possibility that the late heavy bombardment actually helped make Earth habitable.
It's been a really fascinating journey through the early solar system.
It really has. And I think it shows just how much we've learned about our cosmic history.
Yeah, and how much more there still is to discover.
Absolutely. So what's the one big takeaway you want our listeners to think about today?
I'd say this. We have a pretty good idea of when this planetary migration happened, but the how is still a mystery. What caused these massive planets to move? And what would our solar system be like if they hadn't?
Those are some great questions for everyone to ponder, and a huge thanks to you for diving deep with us today and for sharing your expertise on this amazing chapter of our solar system's history.
It's been a pleasure.
And to all of our listeners out there, keep those questions coming. We'll see you on our next deep dive into the mysteries of the universe. Until then, keep looking up.